Hello, welcome to today's lesson. Today we're going to be talking about inverse functions. Inverse functions. Well, we're still taking composite functions, but this is a special class of composite functions. If I start here at x and I apply the f rule, I get the output, f of x. I use f of x as my input for the g function, which I apply the g rule, and it brings me back to x. So I can see that if I do the f function and then the g function, I get back to x. In this case, we'd say g of x is equal to the inverse function. And here I'm starting with x and I do the g rule first, and that gives me an output of g of x. I use my output as the input to the f function, so I get f of g of x, and that brings me back to x. So I see that the inverse of the f function gives me x as well. Notice if this is the case, if you do a composite function, you apply one rule and the other, and it brings you back to what you started with, then we say the functions are inverses. In that case, then f of x is equal to the inverse of g of x, and g of x is equal to the inverse of f of x. This diagram may look confusing, but really all we're saying is you input it, you do a function, and then you do another function, and you get back what you started with. So if I input 5, if I do g of x, and then I take that output and I do f of x, I wind up with 5. If I input 6 and I do the f rule, and then I take the output of that and I do the g rule, I'll wind up with 6. And this little -1 as an exponent is called the inverse. An important note is that f -1 here is the inverse, which doesn't equal when I have a -1 outside the whole function. This is the reciprocal function. An important concept with inverse functions is that the domain of f, the inputs for f, are the same as the range for its inverse. So I'm inputting x's here. Here's my domain for the f. And when I come back, it's going to give me the output. It's going to be the output from my inverse is going to give me whatever my domain for f was. And my range for f, here's my range for f, those act as the inputs for the inverse function. So the important concept is the domain of f is the same as the range of its inverse. And the range of f is the same as the domain of its inverse. The functions f of x equals 2 to the x and g of x equals log 2 to the x are inverses. They are mirror images across the line y equals x. And I just was talking about how the domain and range switch. My domain here is x, it becomes my range on its inverse. My range here is 1, it becomes the domain of my inverse. How do you find the inverse function? The easiest way is to switch x and y, and then to solve for y. Here's an example of finding the inverse. Say we're given y equals x squared. That is this red curve here. It's a parabola. How do I find the inverse? Switch x and y. So I get x is equal to y squared, and then solve for y. Square root both sides, and I get y is equal to plus or minus the square root of x. Well, we see that that's the blue curve here. One important note to make is that the function, the original function, the red one, and its inverse are mirror images of each other over this line, y equals x. That's a line with a slope of 1 over 1 through my origin. And where does the red curve and its inverse, the blue curve, meet? They meet along this line at 0, 0, and 1, 1. And the last point is that we have interchanged our x and y values. For example, on the red curve, the original function we had -2, 4. On its inverse, we have 4, -2.